In this lesson, we'll configure Docker Compose to run our virtual facility and workflows service applications, as well as provision a dedicated PostgreSQL database for each application. If you're not familiar with Docker Compose, it's a tool for defining and running multi-container Docker applications. With Docker Compose, we can use a YAML file to configure our application services. Then, with a single command, we can create and start all the services from our configuration. Let's start by creating a new docker-compose YAML file in the root of our project. This file will contain the configuration for our Docker Compose setup. Again, you can find the content for this file below the course video. Also, we will need a Docker file that will be used to build the Docker image for our applications. Let's create a new Docker file in the root of our project and add the following code. With this file in place, let's head over to our terminal and run the following command. Docker compose up. To test that everything is working as expected, let's use curl to create a new building again. As we can see, the request was not yet successful. This is because we need to update the virtual facility application to use the workflow service host instead of using localhost, since now our applications are running inside of Docker containers. To fix this, let's open up the buildings service TS file and update the create workflow method to use the workflows-service host instead of localhost. Let's try that curl command again. And as we can see, the request was now successful. Great. However, our services don't connect to their corresponding databases yet. As this is something we've already covered in the fundamentals course, we'll skip over the details and just move right into the code. First, we need to install some required dependencies. We'll be using type ORM for this course's ORM needs, but of course, you may need to use something completely different in your app or organization. But don't worry, everything we're doing in this course would all still work the same. So let's go ahead and install nestjs/typeorm, typeorm, and pg for Postgres. Once the installation process is complete, we'll create two entities, building in the virtual facility application and workflow in the workflows application. As these entities will live in separate applications, we won't be able to declare a one-to-many relationship between them. Instead, we'll use a building ID field in the workflow entity to store the ID of the building to which the workflow belongs. Next, let's make sure we update the virtual facility application module to import the typeorm module and configure it to connect to the virtual-facility database. We'll also need to update the Workflows Service Application module to connect to the Workflows Service database. With this in place, let's open up the building service file and use the typeorm repository here, replacing all of the mocked methods. Next up, let's update the buildings module TS file to import typeorm module.forFeature, passing in the building entity to the array, so that the service can inject the buildings repository. And likewise, let's update the workflows service TS file, replacing all of the mock methods here as well. And let's not forget the workflows module, and let's make sure we import the typeorm module for feature, passing in the workflow entity here as well. Great. Once again, we're moving fast here since we've covered all of these basic ORM concepts in the fundamentals course, but you can find the code to copy-paste below the course video as always. Moving on to newer topics, to reuse data transfer object classes between applications, we'll need to generate a new workflows library using the Nest.js CLI. Let's head over to our terminal and run the following command: nestglib workflows. Let's start by removing the unnecessary auto-generated files from the workflows library. Next up, we'll create a new DTO directory and create the create-workflow.dto.ts file representing the data transfer object for creating a new workflow. Before we proceed, let's install the class transformer and class validator packages that we'll use for validation purposes. Finally, let's declare the createWorkflow.dto class and add the necessary validation decorators. Next to this file, let's create the update-workflow.dto.ts file representing the data transfer object for updating a workflow. Lastly, let's update the index.ts file to export both of these classes. Great! Now, with this in place, let's open up our workflows service file and update the create method there to use our newly created createWorkflow data transfer object. We can also remove the auto-generated DTO classes here, which were previously generated by the NestG resource schematic. Another thing to note, let's not forget to update the workflows controller file to use these new data transfer object classes as well. Great, so let's save our changes, and to achieve maximum type safety, let's update the buildings service TS file to use the workflows library data transfer object class also. Excellent. Since now our service returns JSON instead of plain text, let's make sure to change that res.text method to res.json. And lastly, for debugging purposes, let's log the response body to the console. With this in place, let's save our changes, head over to our terminal, and run the following curl command. As we can see, the request was successful, and we can see the response body in the console. Great. This means that we successfully created a new building. So let's switch to the other terminal window and check to see if the workflow was created as well. Perfect. As we can see, there's a new workflow with the name myWorkflow, and the building ID is set to 1, just as we passed in our curl command. Great. We now have two microservices that communicate with each other, all while using separate databases. We're starting to make some real progress already. Awesome.